Hi kids, I'm back. It's Mr. Krause from Mr. The better half, maybe the worse half of www.NK. K stands for Krause. N stands for Newman. She's my partner in crime, my colleague at work, and my business partner. NKinfinity.com. That's where all of this material can be found. Yeah. That's where that's where a listing of all the videos and such. Otherwise, you can also go to www.algebra2commoncore.com. We also will point you to NK Infinity as well. Anyway, my name is Mr. Krause, but for the next, 20, 30 minutes, you can call me Mr. Key, because I'm here to help ye. Oh, I'm a poet. Didn't even know it. Anyway, let's get started. A one-to-one function. Well, you know what a function is, right? A function is where you have every x value has exactly one and only one y value. Well, a one-to-one function is a function, so therefore, no repeating x values. Which means each x has only one y. Now, I didn't really need to put that. I said it's a function, and by definition of a function, each x has only one y. But I'll put it in there for those of you. So it's a function in which each y value has one and only one. One is the loneliest number. Oh, I'm an artist and a singer. So each y value has one and only one x value. So in order for it to be a function, no repeating x values. In order for it to be a one-to-one function, so that's more specific, no repeating. Repeating is one of those words I just have a hard time spelling. Repeating x or y values. So neither one of them can repeat. You can't repeat the x's and you can't repeat the y's. Okay. I probably should put and. No repeating x and y values. No repeating x and y values. So, our goal now is to determine which of the following are one-to-one functions. So in order for it to be a one-to-one function, it first has to be a function, no repeating x's, and then it has to have no repeating y's. So, does it pass function? -2 goes one place, 0 goes one place, 5 goes one place, 9 goes one place. Yes, this is a function. Is it a one-to-one function, which is what we're really asking, is our final answer, is it a function? And right here, notice that this 6, if you turn these arrows around, go to 5 and to 9. So no, not one-to-one. All right. Is this a function? Now, 1 only goes one place, 2 only goes one place, 4 only goes one place, -1 only goes one place, and -2 only goes one place. So yes, this is a function. It also passes the vertical line test. But notice this point right here, which is -2, 1, and this point right here, which is -1, 1, have repeating y values. So no, not one-to-one. Is this a function? Yes, it passes the vertical line test. Is it a one-to-one function? Well, let's just take a look at these two specific points. Or we could take a look at these two specific points. But these ones are easier, so we'll do these. This is the point 0, 1, and this is the point 4, 1. There's my 4s again. Notice the y is repeating, so no, not one-to-one. Is this one a one-to-one function? Well, it is a function. It passes the vertical line test. Now, can you find any points where there's more than one y value? Is there another point that has a 2 as a y value? Any place else along that line right there? Any place else have a 2? Nope. Any place else have a 3? Nope. Any place else have a 4? Nope. So yes, this is 1-to-1. Any other place have a 3? Can you find a 3 any place else? Can I find a 0 any place else? Any positive 2s any place else? No. So yes, this is a 1-to-1 function. That's weird, the phantom. It'll go away in a second. So this one is a function. It passes the vertical line test. But is it a 1-to-1 function? Well, are there any other places where I could get a 1? Well, probably over here, but that's hard to see. How about a 0? There's a 0 there. There's a 0 there. How about a half? There's a half there. There's about a half there, and there's about a half right there. So, no, not 1-to-1. We'll talk about it. For those of you who see something, it's great. We'll talk about it in a minute. This isn't even a function, so I don't even have to answer. That's not even a function, so it can't be a 1-to-1 function since it's not a function. Notice this point has -1 as a y value. This point has -1 as a y value. So no, not 1-to-1. It is a function, but it's not 1-to-1. And these ones are kind of tricky. You got to be careful. Remember, we go back to these step functions. It is a function. It passes the vertical line test. But here the y value is -2, and here the y value is -2, and here the y value is -2, and here the y value is -1, -1, and -1. And here the y value is 1, y value is 1, y value is 1, y value is 2, y value is 2. So not 1-to-1. So, yeah. Let's go back, because that was a little bit tricky. Let's go back. Well, let's talk about this. In order to determine if a relationship is a function, and I should say we have a graph, we use the vertical line test. In order to tell if it's a 1-to-1 function, first it has to pass that it's a function, pass the vertical line test. Then it has to pass what's called the horizontal line test. Horizontal line test. Now remember, vertical lines are straight up and down. Horizontal lines are left and right. So if I go back and I take out my red marker, all the ones I said no, let's see if it passed the vertical line or the horizontal. Well, this one's impossible because it's not graphically. But did this pass the horizontal line test? Nope, hit 2 points. Nope, hit 2 points. Pass the horizontal line test? Nope, hit 2 points. It's 2 points all over the place. So not. Does this one pass the horizontal line test? Yes, there's no place I can draw a horizontal line in. No, I don't care how far to the left and how far to the right I go. I'll never hit that graph more than once. Oh, failed the horizontal line test. Failed the horizontal line test. Failed the horizontal line test. Not a function. This one wasn't even a function because it failed the vertical line test, but it also fails the horizontal line test. Circles are just nothing. Yuck. Blech. Passes the vertical line test, but fails the horizontal line test. Fails the horizontal line test. Fails, fails, and fails. Sorry, fails the horizontal line test. So, this graphically, the horizontal line test is the easiest way to tell if something is a function. But you need to remember that you can't have repeating x values and y values because this one, you can't say on your rationale, oh, it fails the horizontal line test. Well, yeah, what? It's not even a graph. How can you do that? So that use only if you have a graph. All right, I'll be back in a second. All righty, let's keep going. Let's keep going. We are now going to talk about inverse relations and functions. Inverse. Let's just do the dot over to the word inverse. Inverse relations and functions. So I like to think of inverses as opposite. Opposite is a word I can't spell. Opposite. Got it written right over there. So what is the inverse or the opposite operation of addition? Oh, subtraction. What is the inverse or opposite operation of division? Oh, multiplication. So to find an inverse, well, we use inverses all the time to just kind of undo things. To find opposite, so opposite. So to find inverses of functions, what we're going to do is switch the x and the y. Now that sounds really simple, and for linear function, it is pretty simple, but not for all. So let's talk about this one. Here's our, well, let's see, is it a function? It's -3, it's a function. So let's find the inverse of this function. Well, in order to do that, I'm just going to switch the x and y's. This would be -2, -3, 2, -2, -1, 1, 1, 3. There, switched them. All right, so if this is my function, this would be my inverse function, and I would just go 30 goes with 3.4, 40 goes with 5.0, 50 goes with 7.0, and 60 goes with 9.2. That's my inverse. Here's another example. So my input would go here. This is my new input for my inverse function. And since we're doing a mapping diagram, we got to kind of map this thing over. And here will be my output. Looks like a loaf of bread. I know you're thinking, Krause, you are one heck of an artiste. So 38, 40, 50, and 75 would go here, switching the x and the y. 0, 24, and 36 goes here. Now let's see, 0 went with 75, so 75 goes back to 0. 24 went to both of these, so and 38 went with 36. So that's what that would look like. All right, let's move on. Inverse relations and functions. Graphically, switch the x and y. Oh, graphically, I'm terrible at these. So let's see. This is the point -1 or 0, -1. So if I switch that, it would be -1, 0. This is the point 2, 0. So if I switch that, it would be 0, 2. This is the point -2, -2. If I switch that, that would be -2, -2. This here, the point -4, -3. If I switch that, that would be -3, -4. Let me get one more. This is the point 4, 1. If I switch that, that would be 1, 4. Oh, you notice the inverse is just that line right there. I'm going to go to red so it shows up a little bit better. I'll be right back. All right, we're going to do this a few more times, and I think we're going to get the point. Let's see what we got. We got red. So this is the point 0, 0. When I switch it, it's 0, 0. This is the point 1, 1. When I switch it, it's still 1, 1. So we need one more point. This is the point 4, 2. When I switch it, it becomes 2, 4. So I want to make that a nice smooth curve. It's going to have to look something like that. All right, let's go over here. The point 1, 0, 1 switches to 1, 0. The point 1, 3 switches to 3, 1. And it's going to look something like, oh man, that's awful. It'll look something like, that was rough. All right, let's try this one. Well, if I switch these points, they stay. 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 That's weird. Switch this point, it stays. If I switch this point, negative 1, 1, that goes to 1, negative 1. And then negative 2, 2 goes to 2, negative 2. Oh, that's just going to be... So the inverse of this function is that in red. So what simple reflection is happening to these? Do you see it? You learned it in geometry. What simple reflection is it? Reflection. Is it a reflection in the y-axis, x-axis, origin, or do you remember a reflection in the line y equals x? If I draw the line y equals x in each of these cases, do you see the reflection? Now this one's a little weird. If I draw the line y equals x in, notice one of these lines was on the line of reflection, which is why it didn't move. But all of these points went down here. So a reflection in a graph is, or a inverse graphically is a reflection in the line y equals x. Now, because we're switching the x and y, the domain of the function is the range of the inverse. We're switching x and y, which if x is the domain and y is the range, we're really switching the range and the domain. So the range of f of x is the domain of the inverse. So to find an inverse relations, we switch x and y. To find the inverse of a graph of a relation or a function, we reflect over the line y equals x. Be right back. Okay, so we're going to move on a little bit. This next page is we're going to do a little bit of algebra. I know you're excited. All right, we're going to do a little bit of algebra. So if y equals x of x as an inverse, that also is a function, it's written like this. This is how this is our inverse notation. So f, this is read f of x. This is read f inverse of x. F inverse of x. All right. So I want to find the inverse of this, and I want to state it in inverse notation. Well, the step one is to switch the x and y, just the x and the y. So my new equation would be x equals negative 3y plus 4. So step one, switch x and y. Step two would be solve for y. So we're going to solve this for y. So to solve this for y, quite honestly, I hate having a negative y. So I'm going to move this y over to this side. So when that y comes over there, it becomes positive 3y. And I'm going to move the x over. I'm going to subtract the x and bring it over. Negative x plus 4. Well, I'm not done yet. I still don't have y all by itself. My last step is to just divide by this 3. And divide everything by the 3. So I get y equals negative 1x, or negative 1/3 x plus 4/3. If you don't like that, you can write it as y equals negative x plus 4 over 3. Either way is acceptable, except that you have to write using inverse notation. Right, using inverse notation. So I would write f inverse of x is equal to, you can either write negative x plus 4 over 3, or you can write it and split it up. I don't really care which. All right. So the first thing we're going to do is switch x and y. So I get x equals 1/3 y plus 9. Now, I'm going to teach you a trick that I use all the time. I use it all the time, and because I hate fractions. Actually, I don't mind fractions, but you hate fractions, don't you? So I want to get rid of, and this 3 is the problem right here. This 3 right here. So I want to get rid of that. And the way to get rid of anything that you want to get rid of is I'm just going to multiply through by whatever that number is. But I've got to multiply everything through by that number. So I'm going to multiply. Basically what I'm doing is multiplying both sides by 3. So I end up getting 3x equals. Now these 3's cancel. That's why you do it. 1y, or just y, plus 27. Now I got to solve for y. I'll bring the 27 over. I get y equals 3x minus 27. Now you write it in inverse notation. So f inverse of x is equal to 3x minus 27. And finally this one. We're going to switch x and y. Let me do it in a different color. How about we go black? Switch x and y. So I get x equals negative 60.13y plus 52.58. Now I hate when my y is negative, so I'm bringing this over to here. So I get positive 60.13y is equal to, I'm going to subtract the x and bring it over there, negative x plus 52.58. And finally, I just got to get y by itself, so I got to get rid of this silly 60.13. And I'll write my final answer in inverse notation. F inverse of x, as crazy as it sounds, is negative x plus 52.58 over 60.13. Okay, just a reminder, horizontal line test, what are we going to use it for? The vertical line test is used to determine if it's a function. This is used to determine if it is a one-to-one function. The horizontal line test determines where y values repeat. And it also is used to determine if the inverse is a function. So if it fails the if it fails the horizontal line test, the inverse is not a function. So it can be a function if it passes the vertical line test, but in order for its inverse to be a function, it has to have passed the horizontal line test. All right, so our function, which we'll call f of x, and our inverse, which we'll call f inverse of x. Let's see. Let's do it 3 different ways. I've taught you 3 different ways today. Method 1, switch the x and y's. So I'm just going to go through these 2 points. Negative 2, 2, 0, 3, and 2, 4. Algebraically, we're going to call this y, so we'll switch the x and y. So x equals 2y minus 13. We got to bring the 13 over, so we get x plus 13 equals 2y, and divide by 2. So f inverse of x is equal to x plus 13 over 2. And finally, graphically, you'll remember we have to reflect over the line y equals x. So basically, we're just going to switch points. So this one is going here, and this one is going here. That's weird. So now I got to grab this one, which is 3, negative 2, and I got to go negative 2, 3. So this one is basically going to be, that is its inverse. Wow, that's freaky deaky. Anyway, there it is. those are those. I want to real quick talk again about this vertical horizontal line test used to being able to tell the inverse is a function. Let's go back up to this page right here. This original one passed the vertical line test, or horizontal line test, and vertical line test. So notice its inverse is a function. It passes the vertical, or excuse me. Notice its inverse is a function because it passes the vertical line test. This one here passes, the original passed, why do I keep doing horizontal? The original passed the horizontal line test. So its inverse will pass the vertical line test. Same thing here, but this is the one that I want to get to. So let's target this one real quick. So this one is a function. It passes the vertical line test, but notice it fails the horizontal line test. And if you remember, what I just erased was, isn't the inverse of this function this? And does that pass the vertical line test? So the inverse is not a one-to-one function. So basically, if it's one-to-one, the inverse is a function. If it's not one-to-one, then the inverse will not be a function. Make sense? I hope so. All right, kids, that ends day 3. Day 3 is over. Yay!